Let's imagine that I want to find the factors of a long polynomial and I happen to have my TI calculator handy. And say the polynomial in question is the one from our problem set, x to the fifth minus 9x to the fourth plus 13x cubed plus 69x squared minus 194x plus 120. That is a fairly tedious looking thing to try and factor using the rational root theorem and synthetic division. We will graph that out and see what it looks like. We look at the graph and we see that in fact actually it looks like it crosses the x-axis 1, 2, 3, 4, 5 times, which makes sense given that we see that the polynomial has a factor as an exponent of x to the fifth. So there are a number of ways of doing this. One is I happen to be glancing up here, and if I look at the table right here, second graph gets me into the table, is a table of values. And I note that -3 is 0, 1 is 0, 2 is 0, 4 is 0, and 5 is 0. Those are my 5 zeros for this polynomial. I've just factored it. Factors are x plus 3, x minus 1, x minus 2, x minus 4, x minus 5. I'm not always so lucky, right? The table happens to be showing me whole numbers. So let's go back to the graph and take a look at how we might try and find these factors if I didn't know that they were all whole numbers. So what I'm going to do is I'm going to click the trace button, and you'll see on the screen that I have my x-coordinate, x equals 0, y is 120 right now. I'm going to scroll a little bit over to the right here. And what I'm looking for is I'm looking for my y value, which is currently positive. I'm looking for that moment when it goes negative. I can see my cursor blinking at the top of the screen in the middle of the polynomial now. And my y value just went negative. I just leapt across the x-axis. So it means that between that flashing point and that flashing point, there must be a 0 because I must have crossed the x-axis. So I'm going to go back to the left-hand point, which you'll note in this case is the upper one, but that's not always true. I'm going to say second trace, which is actually the calc button, and I'm going to hit 2 because I want to calculate a 0. And it asks me for the left-hand bound. It's asking me for a point to the left of the 0. Well, I happen to know that I'm on a point to the left of the 0 right now, so I'm just going to hit enter. And then it's asking for the right-hand bound, so I am now going to tap the right arrow, and now I have leapt across my intercept. I know that this point is now to the right of my 0. I'm going to press enter again, and ask me for my best guess. Now I can put in anything I want. In this case, there is no way for me to choose anything between these 2 points because they are exactly on either side of it in this zoom level. So I'm just going to hit enter one more time. It's going to calculate and check it out. It's going to say, hey, there's a 0 at x equals 1, y equals 0, meaning that one of the factors of this polynomial is x minus 1. If I repeat this process, if I continue to trace along, and I'm now looking, my y is now negative, so in the next intercept, I'm looking for that moment where my y is going to flip from negative to positive, and I've just found it. So I go back to the left of my 0, right there, second trace, which is the calculate button, 2 to calculate a 0. I'm going to pick the left-hand bound, the point immediately to the left of my 0. I'm going to hit enter. I'm going to tap to the right and pick a point to the right of my 0. So there we are. It's asking me for a guess. Well, there is no point in between this, so I'm just going to leave it as is. It's going to chug along and says, oh, look, you have a 0 at x equals 2, y equals 1. So I know that another factor is now x minus 2. And if I continue doing this for each and every intercept on here, I can find all my intercepts, even if they are not convenient whole numbers, which the table reveals to me. One thing to note about the table view, and I can get to the table view by going second graph, which is also the table button. And I can just scroll up and down through the table to see all of my x and y values, or all my whole number x and y values. I can adjust that so it's counting by different increments in the x, but whole numbers, ones are usually pretty convenient. So that is how to factor using your TI-84. Or several approaches to factoring using your TI-84 that don't involve having to know about the rational root theorem or synthetic division, which I view as a big win.